So here's the beginnings of my 8+ foot beast that I'm making here. The bigger tube is one I got from the UPS store. It's a poster tube, and it's really burly, nice and thick walled, so it's got some pretty good weight to it. Then the other one's a gift wrap tube that's quite a bit lighter weight, and that'll actually help keep the rocket a little more stable having the weight in the base. To make this transition piece, I glued up a bunch of balsa wood, and I traced the inside diameter of the larger tube onto a piece of paper and tried to match it with this thing called a fly cutter. And this thing has an adjustable arm, so you can make any diameter circle on it, and it spins around with your drill press and cuts out a circle. You just test fit a few. And what I did is I got some plywood, thin lightweight plywood, and put 4 sections of the 1/4 inch there, cut out some circles, glued them together. So that fits in the one tube. Did the same thing on this side. And after I got those two on there, I kind of hogged the bulk of the material away with the belt sander, just spinning it around. And then I chucked it in my drill press. I stuck a screw in there and chucked it in my drill press, and actually had a board with a pin in on the other end to support the other end and keep it twisting true. And so I made like a mini lathe out of my drill press, and that worked out for the transition piece. Got myself a little cone going too. I'll go ahead and put it together so you can see the beginnings of what this thing's going to look like. So here's a little picture of just how ridiculously long this thing is. For size comparison, I put a kit I just got next to it by Aerotech called the Mirage, and that's a 7 foot, I think 4 inch rocket. So this one's got an easy foot on that. And anyway, the next step, what I'm going to do is actually try to fill in all the little spiral lines on the tubing with some, I'm just going to use some good old drywall putty that I can mix up and dries quick. And then I'll sand it all down and glue the transition to the top piece, glue the cone in. It's actually going to pop off in the middle when we do an ejection, so I'll show you after I get that all squared away. So here it is after some time with some quick set and a credit card. Looks like a giant candy cane, and filled in any imperfections, and we'll sand it down afterwards and start painting. Here they are all sanded down and ready for paint. Seem to work really well on the big stiff tube, but the flimsier tube, the smaller one, some of it's crackling out a little bit, but when it gets soaked with the nice spray paint, that should hold it in, and I can fill it in with spray paint as we go. Putting a couple coats on the tubes, but I came up with a template for the fin pieces, and I just popped a couple of nails through the edge of the board that's going to be cut off, and then you can just gang cut them on a bandsaw. It makes it a lot quicker. So there are the fins after I cut them out and sanded them down a little. I was going to create a taper on the top, but this is very, very hard little plywood sheet, so I skipped that. A little tip there is if you drill a little 1/16 inch hole and stick a finish nail in there, now you got something to hold it by while you're painting it. So there we go. I'll get these painted and show you them. So for a motor, I'm going to be using Aerotech's reloadable system. I'm going to use a 29mm one, and I needed to make a motor mount for that, so I took a paper towel tube, a bit longer, wrapped it around there, and super glued it. Used my fly cutter to create some wheels that will center it into the rocket there. To retain it in there, the lid actually has a little rim on it, so that'll keep it from going in this way. To keep it popping back out for the ejection charge, I use a metal little skewer that I bent to shape, and then also bent up and glued into the back side of this right there to keep that from causing it to torque this way or to pull out. But that's all there is to that, and I'll glue that in the rocket. I started putting the fins on. I went ahead and used a 5-minute epoxy. But direct gluing the fins on these larger rockets is not as strong as you might want, and since I can't do an easy through fin design, I'm going to use these little things I made. I cut out of plywood, and it's basically a little, I don't know, it's going to be hard to see, but I cut a 45-degree angle corner, sanded off the little sharp inside, and painted them black. And what I can do is basically use it as a fillet to go in alongside the fins to help strengthen it. So that's what those little doodads are, and I'll show you after it's all done. Here's my ginormous 40-inch parachute I made for the rocket. I just used a bath shower liner that I got at the dollar store. It's not not as thick as I'd like, but it should do all right. I'll tape the corners up real good and use some kite string to make a parachute string for it. Well, here's the finished beast. It's hard to even get in a single shot, but I made a little stand for it with 1/4 inch rod. Here are the fins with the fillets on them, and it just goes way on up about a 6-foot rod, and the rocket is about 8 foot 9 inches tall. So that's ridiculously tall. But everything's in there, the 40-inch chute. And we'll give it a test run, and I'll videotape it. I'm going to put some sheet metal on the bottom there to protect the wood, but we'll see how it goes. So I just finished loading the little reloadable motor system I told you about. 29 millimeter motors. The 40 to 120 casing holds E, F, and G motors. This one's an F40 4W, a medium power motor, and it should be able to get my rocket up to about 400 or 500 feet, maybe a little higher. Thought I'd start low to start off with. And anyway, doing it this way, it'll cost you about $10 per launch as opposed to about $20, $25 per launch. So saves a little money. Still not cheap, but there you go. That's the reloadable motor system. I go into detail about the stand a little bit for those interested. Use a 6-foot section of 1/4-inch steel rod, and I use a little piece of maple down here and drilled a hole that is directly perpendicular and then one that's at a slight angle. Use a bandsaw to create some relief cuts in both, and drill the hole horizontally through for a bolt. So when I tighten the bolt, it cinches down and holds the rod in there. To put this on the plywood, I just did screws through into the 1/4-inch ply, but on the bottom I put a 1/2-inch chunk of MDF down there and glued that to the bottom here, and then put another screw up through into the block. For feet, I just did 20-degree angles on a miter saw. I glued them on, pin nailed them first so they'd stay put, and then drilled the whatchamacallit, little screws. But anyway, simple way to make a inexpensive stand. You can just take like a cookie sheet and drill a hole in it and then put that over here, and that'll be a big deflector for you. Or if you have other scrap metal, that's fine. But probably, I don't know, it cost you maybe 12 to 15 bucks tops. I had everything except for the 1/4-inch rod, so it cost me about 5-6 bucks. Alright, 5, 4, 3, 2, 1.
Let me know if you see it.
Yeah, you see it?
Yeah, I see it.
Right.
It's coming.
Oh yeah. Let me know.
It's going to come right down by us. If it stays here. Oh.
Contact.
So that's the epic first flight of the Titan, and everything looks good still. As you can see, the parachute's still intact and fine. Those shrouds really do help out a lot, and hopefully I'll try it with a G motor next time. That was an F40 4W. Alright.